Welcome to a lesson with Dr. Powell. Let's take a look at the same example that we had before, but let's compute the total force another way. So remember, I think we had 20 and 30 in our triangle. Okay. All right. And so we're finding this is the shape of our dam here. So this is a triangle. So we can think of a centroid. A centroid distance would be 1/3 of the length here, which would be just 10. So what we're going to do for this particular calculation to figure out the force, we're going to pretend that there's a constant pressure throughout the whole thing. The pressure is all centered right there. So the pressure overall will be 62.3 times 10, or in other words, 623 will be the pressure multiplied, so constant pressure assumed over the whole area, which is should be 300, right? I believe 300 because 600 divided, right, or 10 times 30, so 300 would be the area of that triangle. So we end up doing that, and in our calculation we end up getting so 9, 6, and 18, and then put the 2 zeros on. And so again, we get the same calculation. Notice no integration this time. It was all taken care of or pre-integrated in the knowledge of the centroid calculation. In fact, it is instructive sometimes to look at the calculation that we made and actually see the centroid popping out. In fact, let's take a look now. How did the centroid pop out in our calculation? Well, let's see. Our little dA is honestly like a dm here. So let's take that. Let's think of that dm or dA. And what was that? That would be, it was dx, and it was 2/3 times 10 minus x, if x is this guy right there. Okay. And then if you multiply that by, so that was in the actual integral that we were computing. And then we had the pressure. Remember how we multiplied by pressure? And in the pressure calculation, we had we had 62.3x. So we're multiplying that by x and 62.3. Now, if you look at this, if you think about this for a minute, this right here, if we were to divide it by 1 over the total area, is actually equal to, and if we're going from 0 to 30, this actually is equal to the centroid position, because you're finding the average value of position going down this way, and you'll end up getting the centroid. So the centroid is right in here. Now, if you take the centroid and multiply it by, so if you take the centroid and multiply it by area, then those areas will cancel out. Shum, zoom. So centroid times area. And then if you multiply that by 62.3, hey, that would be the pressure calculation we wanted, which was how we calculated the force before, which should be the result. Notice this is exactly what we did up here. 62.3 times the centroid ended up being this pressure calculation. Then the area ended up being right here. Notice how the centroid information swallowed up that whole integral, so we didn't have to use it. Often, whenever you use centroids, sometimes it's instructive to actually find the centroid in the calculation that you would actually do, and that I'll leave that for an exercise and an extra activity for those who desire to do so. Thanks for watching.